Let's go over the problems on the second page of our linear versus exponential practice. So now these are a little more open-ended. We are going to need to pick the type of function, and we're not sort of given the prompt to do so. But generally, we should have the theme this week. It's, are we using linear or are we using exponential for these? With this particular question, so we have the median home price. Oh, this should sound familiar. In a town was $275,000 back in 2015. But each year, the price value is increased by 2.5%. So we got that percentage increase, so we should have a little ding, ding, ding bell going off in our head. All right, that's a relative change, so we probably want an exponential function. And we want to know the price of the home in 2026. So I'm going to set up my exponential function, and then I'm going to plug in the value that I need. So in this case, we're going to call H is the price of our home. And we're starting off at $275,000. And we have that 100% added each year plus 2.5%. So that would be 0.25 as a decimal. And then number of years. And remember, this is years, not since this year, but years since 2015. And it's really important to think about that value, because now in the next part, I'm looking at what is the price of the home in 2026. So I need to know how many years have passed between 2026 and 2015. And that is 11 years. And so I'm going to be plugging in 11 into this equation. So H equals 275,000. 1.025. I just added my two values in there. And then 11 years. And that does come out to approximately $360,823.83 would be the value of the home in 2026. Next problem. So a gas station owner finds that for every penny increase in the price of gas, she sells 120 fewer gallons of gas per week. Now, this is an interesting input-output situation because it's not quite as straightforward as we might want it to be. So if we think about it for a moment, when I think about inputs and outputs, I'm thinking about which causes which. And in this case, it's that increase in that price of gas that leads to a certain amount of gas being sold. So my input is the price of gas. And or it's not even the price of gas, it's the increase in the price of gas. It's like how much you change the price of gas by. So I'm actually going to rewrite that because I don't like that phrase right there. So it's the amount, the price of gas changed. And the output then is the amount of gallons of gas, like how much her amount of gas sold changed. So it's like the amount, the gallons of gas sold, sort of how much has it changed in a way. So I'm going to put how much changed. Now, if we think about this, so you could almost sort of think about it like proportionally, because instead of just a rate. So I'm going to sort of approach it two different ways. So if I approach it sort of proportionally thinking, so if she increases gas by a penny, so if gas increases 1 cent, then the amount she sells goes down 120 gallons. So if she raises the price by 10 cents, how much more or less gas would she sell? Well, think about that. If I'm looking at this right here, this is 10 times. Basically, she raised it by a penny 10 times. So she would sell 10 times as much less gas as that rate. So that would end up being negative 1,200 fewer gallons of gas. Another way to sort of approach this problem would just be using it as a rate of change. So basically, if I sort of created this into a rate, it would be a negative 120 because it's less per penny, gallons per penny is sort of the rate. So for each penny increase, she sells 120 fewer gallons. So if she raises the price by 10 pennies, that would be negative 120 times 10, which would be 1,200 fewer gallons. So we could do this sort of same reasoning here if she decreases the price by 5 gallons. So, here we increase by a penny and it decreases 120 gallons. But if she lowers it by 5 cents, then the amount of gas should go up by 5 times that 120 gallons, which would be 600 gallons. So that's sort of a times 5 amount here. Or if we're using the rate, negative 120, and since it decreases 5 cents, we're decreasing 5 pennies. And so it ends up being 600 more gallons using sort of rate of change thinking. All right, back into exponential. So we have a certain drug breaks down in the human body at a rate of 15% per hour. If the initial dosage was 8 milligrams, how much would be left in the bloodstream after 8 hours, and what's the half-life? All right, so let's set up an equation here. So the amount of drug equals 8 times, and remember, if it's breaking down, we're decreasing by 15% each hour. And I want to plug in 8 hours later. And that comes out to 2.18 milligrams. Now, half-life, we could set up an equation. So you could set up an equation 4 equals 8.85 H, and we could go to our calculator and solve that equation. So remember, the setup would be I'd put in my exponential equation. Oops. And then I'd put in what I want it to equal, which would be half the initial amount. And I can go here and I can see, it's about 4.3 hours. So that's one option, and that's okay. That works. That's great. That's wonderful. So, using a graph, we came up with 4.3 hours. But remember, with half-life and doubling time, we are able to just sort of estimate it with our rule of 70. So we can also use the rule of 70. And to do that, it's just 70 divided by the percent. And in this case, that percent change is 15% is our sort of rate. And that comes out to 4.7 hours. And so it's not exactly equal to what if I solved it, would come up with, but it's close enough that we're good with that. Either of those answers is 100% acceptable. All right, the next problem, we're going to be interpreting an equation. So we are told that the following function models your salary at a new job, where you are given cost of living adjustments each year. And so your salary is equal to $67,000 times 1.032 to the T. T represents the number of years since 2023. What is our growth rate? So we're looking for the R value as a percent. So remember that 1.032, that growth factor, is really equal to 1 plus R. So we need a minus 1 from that. And so R equals 0.32, but we want to write that as a percent. So if we multiply that by 100, that would be a 3.2%, and always say increase or decrease, increase in our salary. Approximately what year will you earn double your current salary? So since I'm told to approximate, I'm going to definitely use the rule of 70 here. So 70 divided by that 3.2, and that comes out to about 21.87. And now it does say in what year. So I took that value and I added it to 2023. So depending on how you rounded it, it's either, the year 2044, if you did 21 years, or the year 2045, if you rounded it up to 22, it's somewhere in between. All right, and last but not least, what is your salary 7 years from now? So that's really, we're just going to make our T value equal to 7. So S of 7, and I'm going to plug 7 in for T and put that all in the calculator, and I would have a salary of $83,528.12. And those are the problems on page number 2. Check out the next video to see the problems on the remaining pages.